Hi and welcome back to this series where we look at Snowflake Cortex in detail, starting with the ML models that Cortex makes available to all Snowflake customers so you can use it on your own data assets that you already have stored and secured in your Snowflake environment. Last time out, we took a look at the anomaly detection model. This time we're looking at time series forecasting. What exactly is forecasting and why would you want to use it? Well, forecasting essentially is the process of making future predictions based upon historical data and trends. It involves the use of statistical models and machine learning algorithms to analyze patterns and trends in past data, which can then be used to predict future values. The primary goal of forecasting is to provide data-driven insights to make those future predictions. And this is really useful because it can help many businesses and organizations make these predictions accurately and plan accordingly. For example, in retail, forecasting can predict future sales, allowing for better inventory management and resource allocation. In finance, it can predict market trends and help inform investment strategies. So by providing a glimpse into the future, forecasting enables proactive measures, reducing uncertainty and enhancing strategic planning. Now, Snowflake Cortex takes forecasting to the next level by integrating these advanced machine learning capabilities directly within Snowflake. That integration makes it easier for you and your teams to get access to leverage the forecasting algorithms. And this integration simplifies the forecasting process. It makes it accessible and efficient and easy to use for you and your teams. So without further ado, let's dive into a demo to see what this looks like and how you can get value from Cortex models in your own environment. Okay, so here we are in Snowflake and we're going to cover a few examples that demonstrate using time series forecasting for different use cases. The first thing we're going to do is we're going to create a sales database to store our tables and data and models within it. We're then going to create a sales data table. Now in here we've got a store identifier, an item, a date, timestamp, the number of sales, and then we've got a bunch of additional variables, temperature, humidity, and holiday, which we're going to use in a later example in this demo. So let's create that table and let's populate it. Now don't forget, if you want to follow along yourself, you can get hold of all of this code directly on the Snowflake documentation website under ML functions under forecasting. Next up, we're going to create or replace a table called future features. This is what we're going to use a little later in our demo. So we're just setting it up now to get our housekeeping out of the way. And we're going to insert some data in there. Notice that it's exactly the same with the store identifier, the item, the timestamp, and then the extra variables we're going to use a little later. So our first example uses a single time series. So that means all the rows are part of a single series. It has two columns, so it needs two columns. It needs a timestamp and it needs a target value column. So first up, we're going to prepare the data set using the sales data to train the model. So we're going to create this view called V1, and notice that we're selecting everything from store ID 1, where the item is a jacket. So let's just have a look at what that looks like in our view. Notice that we're not including the additional variables at this stage. We're literally just pulling out a date and the number of sales. Notice that the way we set this up is our sales increment by 1 every single day. So they start at 2 on the 1st of January 2020 and they go up by 1 in a linear fashion every single day. Okay, so this is obviously a small data set, and the reason why it's set up like this is so when we're forecasting in the future using this, it's quite easy to see how it all works behind the scenes. Now, the following statement here for model 1, this is going to train a forecasting model using the data set V1 we've just created. So we've got create Snowflake ML forecast model 1. We give it our input data, which is our view, but it could also be a table. It needs then a timestamp column name, which is date, and a target name, so what we're looking to predict. So let's execute that, and that'll take a few seconds to run. Once that's ran, we will get a model 1 successfully created statement in a moment. This means now that the forecasting model is now available as model 1. We can call it like this using the following command: call model 1, exclamation mark, forecast, and we're adding this forecasting underscore periods to forecast the next 3 timestamps. So let's execute that and see what it comes up with. And here we can see for our 13th, 14th and 15th of January 2020, we've got a forecast of 14, 14.5 and 15.75. Now, if we go back up to our data, notice that the last increment was on the 12th, and that was 13 sales. So it's predicting it's going to go up by 1, which follows the pattern as we expect. The next one, it doesn't necessarily go to 15, it goes to 14.5. Notice we've got a lower and upper bound here, so basically it's predicting it can fall within this range and forecasting a figure within this range. And then we've got 15.75, so again a little bit less. If it was following the pattern, we'd have 14, 15, 16. But crucially, we've got our 3 timestamps for our forecasting periods that we specified here. Now, interestingly, in the Snowflake documentation, it suggests that the model would predict 14, 15, 16, as we would expect, with the same values for lower and upper bound. But as you can see, it's slightly different here. And so let's try to customize the size of the prediction interval so we can pass a prediction interval parameter in as part of a configuration object. Now, the prediction interval estimates a range of values within an upper and lower bound in which a certain percentage of data is likely to fall. So for example, a value of 0.95 means 95% of the data is likely to appear within that interval. Here we're specifying 0.8, so we're saying 80% of the data is likely to fall within the interval. We can add this value and parameter onto our model when we call it. So if we execute that again, let's see if that changes any of the output at all. Now for our forecasting figures, they remain exactly the same. But on a bigger data set, this is something that you're going to want to know about and be able to use to fine-tune how we use the model and how we apply it to fit our data properly. Again, we saw this in our last video, the anomaly detection video. If you missed that, I'll stick a tag up in the corner so you can go and check out that video to see how that works. Finally, we're going to save our results from the model. So just calling the 3 forecasting periods, grabbing the last SQL ID for the statement that we've run, assigning that to a variable called X, and then executing this create table, my forecasts, and creating the table as a select star from the results for that particular SQL ID or query ID. If we execute that, that will run the model, create the table and populate it with the data that was returned from the model. So if I show you what that looks like, there's our 3 records as we saw a little earlier on. Next up, we're going to move on to forecast a single series with exogenous variables. That means essentially additional variables that we think may or may not influence the target value. In this case, it's going to be holidays or weather, for example. And so we need to include these first of all in our training data. So we're going to create another view, V2. This time we're going to pull in temperature, humidity, and holiday. But we're still going to look at store ID 1 and the jacket items. If we look at the view, here's our data. We can see now we've got the additional 3 columns on the end of it. So in exactly the same way before, we're going to train our model using that new view that we have. Notice that we don't necessarily need to specify now that we're using exogenous variables. We only still need to specify the timestamp and target name because it assumes that any additional columns in that data are going to be additional variables that we're going to look at. So this new model now is called Model 2. And if we want to perform forecasting for future timestamps, we need to provide future values that also include the same variables that we've got in the model. So in this case, the temperature, humidity, and holiday. So this allows us to kind of answer those what if questions. So what if the temperatures were cooler than normal? How does that impact things going forwards? If I just remind you, just back up the top here, we've got this future features table that we created at the top of the video. If we just quickly have a look at that data, we can see here we've got our temperature in there and our humidity. And this is great because you can then play with these values, amend them as you need to, and look at different scenarios to predict future sales values. If we come back down to executing the model itself. So if we come back down to where we were before, we're going to create a view v2_forecast, and we're going to select the columns that we want from this features table. Again, looking at store ID 1 and the item equal to jacket. So we're just preparing our data. Here it is in our view v2. So now we're going to run our model with this forecast command here. We give it an input data set, which is our V2 forecast, because this is what we want to use to forecast our projections of sales. Here, though, we don't need to specify an interval, a prediction interval like we did before, because it will work that out based upon the number of timestamps we're providing in the forecast, in the V2 forecast view. We do also need to tell it what is the timestamp column name. If we execute this, it gives us the next two timestamps, effectively the same number as what we passed into it. The forecast values are the same. So we're working with a really small data set. It's not going to give us a huge amount of variation in terms of the result set that we're seeing, but hopefully the theory makes sense and how you would apply it in your own environment. So you too can use Snowflake Cortex and these ML functions that are now available to you and every Snowflake customer. Hope you found this useful. If you did, keep watching, keep subscribing. New videos coming soon.